Picture this. You are sitting in your exam hall. The clock is ticking down. You flip the page on your Cambridge O-level mathematics paper, subject code 0580, and you're hit with a massive wall of text. Now, I see two types of students in this exact scenario. First, we have students like Alex. Alex panics, overloads the page with every single raw mathematics formula they've ever memorized, completely ignoring the actual analysis of the question. Then we have students like Sam. Sam rushes, Sam looks at the clock, speeds through the reading, and totally misses the specific command word requirements hidden in the text. Both Alex and Sam lose massive marks, not because they don't know math, but because they don't have a strategy. Well, welcome to the Explainer, where we completely change that. We're going to treat Cambridge math problems like an archaeological dig, methodically uncovering hidden clues to master ratio and proportion. Layer by layer, we are going to reveal the perfect answer. I'm absolutely thrilled to guide you through this today. Mathematics isn't just about crunching numbers, it's about scraping away the distractions and finding the structural logic underneath. Today's focus is ratio and proportion, a topic that forms the absolute bedrock of so many complex exam questions. Let's dig in.
Okay, let's look at our excavation plan for today. We are breaking this down into 5 core areas. First, the rules of ratios. Second, maps scales and the 1 to n format. Third, finding the unknown quantity. Fourth, dividing by given ratios. And finally, number 5, direct versus inverse proportion. We'll be moving from foundational simplification all the way through to the tricky terrain of inverse proportion.
Section 1, the rules of ratios, establishing the foundation. We have to begin our dig at the absolute foundation of the subject. You literally cannot build a massive architectural wonder without solid ground, right? In mathematics, that means knowing exactly how to establish and simplify the sizes of different parts.
Now, what's absolutely crucial to understand about this slide is that simplest form isn't just a suggestion. It is our baseline expectation for every single exam answer. Remember our student Sam, who rushes through exams? Sam might calculate that 10 sweets divided between 2 people means one gets 6 and the other gets 4. Sam writes down the ratio 6:4 and immediately moves on to the next question. And just like that, Sam loses marks. Why? Because the examiner is always looking for the simplest form. You must look for that common factor. Both 6 and 4 can be divided by 2, leaving us with a beautiful, clean 3:2 ratio. Just like essay subjects have the Peel framework for paragraph structure, in mathematics, your framework demands that your final point is always fully simplified.
Before we dive into the most dangerous trap on the slide, I have a quick reminder. Before we continue, subscribe to our YouTube channel, Ace the Exams, at AceTheExams_IGCE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's talk about the unit conversion trap. This is where examiners love to hide pitfalls to test your attention to detail. You must always ensure you are comparing identical units before you even attempt to simplify. Let's say the question asks you to simplify the ratio of 1 kilogram to 200 grams. If you're like Alex and just blindly write 1 to 200 without analyzing the units, the trap has sprung. You have to convert that 1 kilogram into 1,000 grams first. Now you have 1,000 grams to 200 grams. Because the units are the same, we can drop them completely from the ratio. We divide both sides by 200, and our final, simplified, full mark ratio emerges perfectly as 5:1. Section 2, map scales and 1 to n, standardizing the clues. Let's move to our next site and see how this foundational rule builds into standardizing ratios into the specific 1 to n scale format. This is all about command word decoding. Whenever an exam question specifically asks for a scale or enlargement in the 1 to n format, your simple strategic move is to divide both sides by whatever value sits on the left. It doesn't matter how ugly the numbers look. Let's say you have a ratio of 8 millimeters to 30 millimeters. To get that into the 1 to n format, you take that number on the left, the 8, and you divide both sides by it. 8 divided by 8 is exactly 1. 30 divided by 8 is 3.75. So your scale is 1 to 3.75. You've just standardized the data perfectly. And this image brilliantly illustrates how map scales translate to real-world distances. This is a classic 10580 paper question. Let's say a map is drawn to a scale of 1 centimeter to 2 kilometers. That means every single centimeter on that piece of paper represents 2 actual physical kilometers on the ground. So if the distance between the towns of Amhope and Didburn is measured at exactly 5.4 centimeters on your map, how far is it really? Well, you take that 5.4 and you multiply it by your real-world equivalent of 2. 5.4 times 2 gives us 10.8 real kilometers. It's literally like having a decoder ring for the physical world. Section 3. Finding the unknown quantity, the multiplier key. Next up, we are going to unearth our golden key for unlocking almost every single problem in this entire topic. If you only take away one concept from our explainer today, let it be this.
This is where we see the real transformation in how you answer questions. Look closely at these two giraffe photos. The problem tells us these photos are mathematically similar, existing in a ratio of 2 to 5. We are given the smaller photo's height of 8 centimeters, but we do not know the larger photo's height. Now, our student Alex used to look at this, panic, and try to set up incredibly complex algebra that wasted precious time. But we don't need to do that. By figuring out what the smaller photo's ratio part was multiplied by to get its actual size, we can effortlessly reveal the missing dimensions of the larger one. In this height example, our golden multiplier is exactly 4. Why is it 4? Because the ratio part for the smaller photo is 2. What do we multiply 2 by to get the actual given height of 8 centimeters? We multiply by 4. Now that we hold this key, this multiplier of 4, we simply apply it to the larger photo's ratio part, which is 5. 5 times 4 gives us an actual height of 20 centimeters for the larger giraffe photo. Finding the multiplier is like turning on the lights in a dark room. Everything instantly becomes visible, and you lock in those marks in seconds.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, let's get back to it. Section 4, Dividing by Given Ratios, the 3-step system. Welcome to our interactive workshop. I want you to treat these 3 steps as your absolute blueprint for surviving any division question. Whether you are slicing up inherited money or mixing chemical compounds, this is your framework application. Step 1. Figure out how many total shares exist in the whole system by adding the numbers in the ratio together. Step 2. Take your grand total quantity and divide it by those total shares. What does this give you? Our old friend, the multiplier. It tells you the exact value of one single share. Finally, step 3, multiply each individual part of the ratio by that golden multiplier. Let's do a date and scan challenge right now. Look at this table. We need to mix exactly 1,000 milliliters of fruit punch, where the recipe calls for orange and grapefruit juice in a 5:3 ratio. Let's apply our framework. Step 1, 5 plus 3 equals 8 total shares. Step 2, we have 1,000 milliliters total. 1,000 divided by 8 gives us a multiplier of 125. That means one single share is exactly 125 milliliters. Step 3, orange juice needs 5 shares, so 5 times 125 is 625 milliliters. Grapefruit gets 3 shares, so 3 times 125 is 375 milliliters. Boom, full marks. Now for challenge 2, find the flaw. The biggest flaw I see in exam papers is students not doing this simple check. Remember Sam? Sam calculates the juice amounts, writes them down, and immediately flips the page. Sam doesn't check the answer. Don't be like Sam. Always add your final amounts back together to ensure they match the starting total. In our juice example, 625 plus 375 perfectly equals our starting 1,000 milliliters. This simple habit takes less than 5 seconds, but mathematically proves your working is solid. Section 5, Direct versus Inverse Proportion. Flipping the rule. We are now approaching the ultimate boss battle of our math excavation. This is where you have to stop acting like a calculator and start acting like a logician. For our third challenge, we are focusing on speed and logical evaluation. The crucial point here is evaluating the real-world relationship. Direct proportion is super intuitive. If you need 200 grams of flour to bake 10 cupcakes, you logically need 400 grams to bake 20. Both numbers go up together. You find the multiplier and you multiply. But inverse proportion is a trap. In inverse proportion, as one quantity goes up, the other must go down. If you hire more workers, the time it takes to build a bridge decreases. Here, you don't multiply by your multiplier, you divide by it. Let's look at a fantastic real-world example to really lock this in. 3 excavators can dig a hole in 8 hours. How long would it take 4 excavators? Well, stop and think. If we have more machines working, it will clearly take less time. The multiplier going from 3 machines to 4 machines is the fraction 4/3. When you encounter an inverse scenario like this, you must absolutely remember to flip your strategy. Instead of multiplying, you take the known 8 hours and you divide it by that 4/3 multiplier. 8 divided by 4/3 gives us 6 hours.
More machines, less time. The logic holds perfectly.
This quote perfectly sums up our complete mathematics answering system today. Look at how far we've come. We've established 3 rules that guarantee top marks. Number 1, command word decoding. Always look for phrases like simplest form or 1 to n. Number 2, framework application, using our 3-step system to methodically break down ratios without panicking. And number 3, the time management matrix, knowing instantly whether a problem is direct or inverse proportion so you don't waste 10 minutes going down the wrong path. No matter the problem, identifying that multiplier is your primary objective.
So, the next time you face a massive wall of text in an exam, will you panic like Alex or rush like Sam? Or will you strip away the noise and find the multiplier that guarantees your final answer? Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel AC Exams at acexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. AC Exams, your Cambridge success starts here.